On behalf of the Applied AI Institute, we welcome you to the course Introduction to Artificial Intelligence or AI. AI has become a buzzword all the way from corporate boardrooms to dining conversations among family members. As consumer products like Siri and Alexa invade our homes and corporations debate how to use AI as a strategic differentiator, we must first understand what is AI. AI started with our ambition to develop machines that mimic human expertise. We studied the human information processing in our cognitive psychology experiments and found many mechanisms we use on a day-to-day basis. How we use perception to hear, observe, and sense. How we use cognition to connect the dots and reason. How we discover, organize, and store knowledge. How we constantly learn and improve our skills. How we collaborate with others to share ideas, negotiate, and work together on a task. We will introduce AI technologies that facilitate machine to augment human information processing and problem solving. We will also discuss the acceleration in the use of AI with generative AI and large language models. Let's get started with a look at human intelligence first. Each of us carries about 80 to 100 billion neurons in our brains. We are good at connecting these neurons based on past experience to a new situation. How do our thoughts wander back to remember a face, a musical note, or a past project in the middle of a conversation? Most of our intelligence comes from synapses, which connects these neurons. While it is hard to count, there are estimates that a professional carries 100 to 500 trillion synapses, and there are thousands of synapses connected to a neuron. In other words, humans are efficient at storing and using intelligence. If we run into memory overload, we start using other ways of storing intelligence on yellow stickies, Word, Excel, emails, or any place we can easily access so we can draw that intelligence or associated facts when we need it. If we now consider organization, we start to share these synapses with others around us. Organizations use a variety of ways to document collective intelligence from their employees, customers, business partners, suppliers, and regulators. Organizations are getting increasingly good at storing data. However, most of the intelligence is currently trapped in documents, whether it's a policy document, procedure document, contract, memos, audit reports, or you name it. They resort to human intelligence to interpret these documents and convert them into actions. Finally, we have the entire public environment where we have information in published internet pages. Once again, most of this knowledge is encoded using documents, videos, images, and spoken words. It requires human mind to connect and use it to convert to action. So now let's see where generative AI fits in. AI has emulated human brain's process for connecting the dots using statistical techniques. In early studies of chess, as scientists studied chess masters, they found that chess masters stored and used chunks of chess positions. This chunking of knowledge is often hidden and uses many layers of knowledge representation. Using deep learning techniques, AI scientists can emulate human chunking of knowledge and store these chunks for future use. This is done using a mesh of connections organized into a series of layers hidden from the user, each connecting the dots from previous layer. The underlying deep learning techniques can work on groups of items to find patterns and can improve its performance from experience, much the same way a person learns from experiences. Imagine giving such a deep learning model a large amount of information from the public sources. It creates its initial set of connections and learns its interaction using feedback. Let me characterize how these models are built and used. Number one, this is all about statistical learning. These models have trillions of parameters. Such a large number of parameters cannot be handcrafted. It has to be learned in a statistical way. Secondly, these are large-scale foundation models, and these models cover a variety of domains, so it is not necessarily created for a single application. Though it is still limited in what it can do, but it does have the ability to work across diverse domains such as business, law, and medicine, and you name it. Large language models, or LLMs, are the most prominent examples of foundation models. Thirdly, model can be privatized. We can tap the public model in ways similar to how we tap the internet today, but we can privately assemble and grow organizational intelligence also. The next characteristics is crowdsourcing. The model is as good as the information it gets from a variety of sources, whether it is from public, whether it is from the individual, or it is coming from the organization. In a pre-trained environment, the model can be executed in seconds, while developing a model is expensive. The CPU time needed for developing the model could be in tens of millions of dollars in CPU cost. However, once built, the model can be used many times. Generative AI mimics humans in creating new content. It can write a poem or a legal document. It can draw images like the ones shown here. It can create music. Generative AI is good at reading, writing, chatting, and creating images. Let's discuss these four major patterns. When you read a large and complex document, you are able to recognize key facts and concepts written in paragraphs or organized in a table. Generative AI can do the same. Giving a set of paragraphs or tables, it can classify these paragraphs based on any categories you specify. It can also extract specific entities such as organization names, dates, or amounts. Like humans, generative AI can write documents. You can give it a large body of text and ask it to summarize using bullets or structure them into a table. You can use generative AI to take a set of bullets and elaborate into an article. You can transform a text from a table to paragraphs or vice versa. You can give a set of instructions and ask it to write a program in any programming language. Generative AI can interpret a user questions, respond to it, ask a follow-on question, and chit-chat about any topic. It can draw images, create tables, graphs, schematics, or edit or change an existing drawing. So the best way to think about generative AI capabilities is to contrast with how we used machine learning in the past. A typical regression model allowed us to create a model and use it to predict a value to help select an alternative. Human work was needed to do all the work that led up to that regression equation and then in interpreting the results. On the other hand, generative AI can participate in all the steps associated with problem solving, all the way from defining or interpreting the problem and finally ending in the solution presentation or conversation with the users. With large-scale data explosion, we sometimes find it hard to find the right data or make a consistent decision. AI offers many important capabilities. It can sift through large data sets much faster, apply customized filters, and it can do so consistently 24 hours a day, 7 days a week without getting tired. The purpose of this course is to showcase to you an important aspect of the mashup, how an expert can encapsulate expertise into an AI system and how an AI system applies that expertise in a variety of tasks and amplifies it across an enterprise. In doing so, AI supports both the expert and the end user and provides important ways to package expertise and then deliver it at the point of decision making. We see many claims for AI where AI is seen a mere extension of machine learning and an automation arm for decision made by simplistic analytics model. Such claim undermine major benefits one can draw from AI technologies. Generative AI is helping us integrate with many such technologies to the forefront, like knowledge graph, computer vision, and conversational AI, to name a few. Human problem solving is driven by 4 major capabilities. Perception is how our brain processes sensors. Our eyes view an object and the brain is able to recognize it. Can computers use perception to replicate our ability to recognize faces, handwritten text, symbols, and images? We use cognition to find solution to a problem. Using a variety of reasoning techniques, we predict or generate a set of responses. Can we use computers to mimic human reasoning? We document knowledge in books and other forms of media and share with others. Is it possible for computers to participate in organization, use and sharing of accounting and medical keywords for finding related articles? We collaborate with each other and solve problems together. Can we include computers in answering call center calls where they can listen to the conversation and perform all back-end queries while the call center agent focuses on conversation with the customer? It is not just a question of mimicking human expertise. We must find ways to place this expertise in production systems and scale to the entire organization. We hope you will learn from this course how to spot AI technologies and find ways to package and deploy your expertise across your organization.